Hi friends, welcome to GNK Tutorials. I'm very happy to share you guys. Today we are going to start some of the basic concepts in the digital logic design. So our subject is digital logic design. So everyone, all of you having very basic question will be there. Why we are using digital logic in electronics and communications and computer science engineering and most of the domains. Nowadays, whatever the device you are considering, all the devices are operate with their digital signals only, right? So that the digital signals means the signal consisting of whether it is a 0 or 1 only. That means our system, which may be laptop or it may be computer or it may be anything, any digital device that can understand the basic language is nothing but binary language. So binary logic means that obviously it consisting of either 0 or 1. So is it possible to directly the system is identify the corresponding 0 value or 1 value? Because of each and every device is an electronic device. These electronic devices cannot understand directly it is a 0 or it can be 1. So that can be recognized with the help of a voltages format. It is a 0 volts can be treated as a logic 0 and logic 0 volts 0 and logic 1 can be treated as a 5 volts. If you are applying the 5 volt signal, that can be treated as a logic 1. If you are applying the 0 voltage, that can be treated as a 0. So that is the scenario that can identify the corresponding numbers in the computer also. Based on this, the corresponding computers performs the whether it is arithmetic operations or logical operations or whatever the any operation that can be carried out based on the corresponding numbers only. Right? So the Boolean algebra is very important. Boolean algebra is a very important concept that is found by the George Boole in 1854 actually. So this main thing is nothing but the symbolic logic resembles the ordinary algebra. This is nothing but Boolean algebra is used to solve the logic problems as well as design of the digital computers. So this Boolean algebra solves the logic problems as well as the digital computer analysis. So coming to the first topic in case of the number system is one of the most important concept. Generally we know that number means which is a count, right? So in case of the number systems, the first topic is nothing but a numbers systems, right? What is the use of number systems in case of the digital logic design is a primary question in our each and every mind, right? So these number systems are used to count the numbers. So basically these number systems can be classified into four categories. That is nothing but first one is nothing but a decimal number system, binary number system, and third one is octal number system, and fourth one is hexadecimal system. Hexadecimal number system. These are the classification of some number systems, right? Coming to the some of the important points in case of the number system, let us see the some observations will be there. That is nothing but first one is nothing but radix. Okay, what is the meaning of radix. Radix is nothing but number of digits in the number system. Radix, it represents the it represents the total number of digits in the number system. That is nothing but represents the radix. As well as radix is also called as the base of the number system. Radix is also called as a base. So suppose if you see the generally any number can be represented as, suppose if you are taking is a n is a number n is equal can be represented as, generally it is something having a integer part as well as a some fractional part, right? Number system is generally consisting of a integer as well as a some fractional part will be there. It consisting of a some integer part as well as a some fractional part will be there, right? Integer positions can be represented as, like, let it be considered, I will consider integers can be represented as a r is nothing but a real part because of it is integer position that can be represented as for generalization purpose a0, a1, a2 up to an. The position of the corresponding number system or positional weight is nothing but positional weight of the corresponding digits is, I will represent it as r power 0, r power 1, r power 2, r power n minus 1. This is a general positional weight of the number system. If you are taking it is an integer position, because we are taking a integer. At the same time, if we go for the fractional position is also some difference will be there. Fractional position can be represented as fractional position. So fractional position can be represented as in the following way, that is nothing but, let us see the situation. So here we can represent the numbers a minus 1, a minus 2 and so on, a minus 1, okay, a minus n minus 1, or we can also represent generally, I will consider a minus a, I will consider some m value, let it be considered a minus m. So the positional weight of these numbers can be represented as, previously we can represent r power 0, right, from left to right. So see the scenario, it is a case of r power 0, r power 1, r power 2. So now we can represent these numbers in the form of a, it can be represented as here r power minus 1, r power minus 2, r power minus m. This is a positional weight of the corresponding integers as well as corresponding fractional numbers. So from this, these are the some of the observations from this. I can represent some numbers from this, where r represents the radix, where small r represents the radix of the number system, r represents the radix of number system. What is meant by radix? The number of digits present in the number system, right? Where small a is nothing but digit in the corresponding set, where small a represents digit. Small a represents digit. Where n is equal to number of digits in the integer position, where small n is equal to number of digits in integer, okay, as well as capital M is equal to number of digits in the, where capital M, small m is equal to number of digits in fractional part, right? So a n minus 1 is the most significant of a minus 1 is the least significant, right? So that is a n minus 1 is so up to a n minus 1 is a MSB bit as well as a minus m is the LSB bit. This is a very brief introduction about the number system, right? The number system means that generally number means that we use it to count, right? Simply we can say that it is a count, right? So from this number system, we can find out the what is meant by radix. Radix means that total number of digits present in the number system, as well as a number can be represented as a like n can be treated as a real part as well as some fraction part will be treated. Okay, this is a scenario. So coming to the decimal number system, okay, so this is nothing but a brief introduction about the number system, how we are going to represent the number system. So